So now we want to find that actual regression line. So the line that goes through that scatter plot to find the exact, not just a random line going through it. So when it comes to it, the good thing is it's literally a line. So if you guys remember some algebra, right? So a line in algebra is y equals mx plus b, and this follows the exact same template. So in this case, right, so being 1 would be considered our slope, right, because m is our slope in this case. And then b naught would be considered our y-intercept when it comes to it. Okay. Right, so that's that portion. And now the rest we can just figure out ourselves. So we can just do this. So first off, the x itself is called the predictor / independent variable. Y hat is called the response / dependent variable and has another name we'll talk about in the later at the end of this section as well. Okay, so those are the main focuses. Now, when it comes to the slope and the y-intercept, we have equations for those. So the b1, the slope, is equal to r, so the r linear correlation coefficient, the r value, times s of y, which is the standard deviation. So s of y is the standard deviation of all the x variables, and s of x is the standard deviation of the y variables. And therefore, and then our y-intercept, our b naught, is equal to our mean over y's, so x bar is mean of just the y's, times b1, so we have to find b1 first, times the mean of the x's, right? So there's a lot of mean stuff happening when it comes to it. Now, in most cases, this is going to be given to you as well because, it just takes too much time to find standard deviation. So pretty much B1 is going to be given to you as long as you, plug it in correctly, and then B naught's the one you're going to have to do more work to deal with when it comes to it. Now, the thing is, you always want to round to 3 decimal places for everything. So your B1 and your B naught to 3 decimal places because you want to be more precise as best you possibly can. Okay. All right. So let's try an example out so you can see how this would work out. Okay. So let's go back to our pizza example. So the pizza subway fare cost is shown below. Find the linear regression line for the paired data set. Okay. All right. So notice, like I said, they gave us SX, SY, and R. And then it's our job to figure out X and Y is. And the good thing is, right, they told us what X and Y is respectively is going to be. Okay. So first thing we want to do is find B1, right, our slope. So that is R, so 0.987 times, and now this is, you got to be very careful, right? According to our equation, it is the standard deviation of the y's first. So the standard deviation of the y's is 0.707 divided by 0.739, like that. Okay. So if you do this correctly, I believe you should get roughly 0.945 as your slope. Okay. And now to find your y-intercept B naught, it is the mean of the y's, so we're going to have to find the mean of all the y values, so this is the subway fees. So if you add them all up and divide by, in this case, 1, 2, 3, 4, 5, 6, I believe the mean of the y's should be 1.06. Okay? And then minus, because again, our equation says minus, right? So minus RB1, so which is 0.945, times the mean of the x's. So now we go up and just find the mean of all the x variables, in this case the cost of pizza, which you should get roughly 1.08 there. So then finally, multiplying and subtracting, our y-intercept should be approximately 0.034. Okay, and now we put this all together. So now our y hat, because it's a line, right, is going to be now, I don't mind if you guys flip it, but it preferably be your y-intercept first plus that portion. But if you want to put your slope first, I'm not going to be that picky when it comes to it. But it should look like this. X. And there is our line. So what this means is if I literally plotted every single point, so right, this is x's. So give you a quick little example. Right, here's 0.15, 0.15. So if I plotted every point on here, this one, I can also plot the line that goes right through them all as best as possible when it comes to it. Okay. So that is our regression line itself. And this is used a lot, and especially if you go into business itself, when you want to predict what's actually happening in the future. which also we'll talk about in a little bit as well. Okay. All right, let's do one more question on that. So question 4. So back to our left arm and right arm. So find the linear correlation, linear regression line for the paired data. The data is the given blood pressure. So same scenario. And also, like I said, right, they give you this information as well. So right off the bat, we can find what B1 is. So 0.867 times y goes on top, so 17.254, and x goes on the bottom. So our slope is going to be roughly 1.315-ish. Okay. And then we go to our y-intercept. So first we got to find the mean of the y's. So, how do we know it's y and x? That's a good question, right? Well, notice what it says here. Make the independent variable the right arm and the dependent variable the left arm. So let's go back to our definition. What is the independent variable? X's. What is the dependent variable? Y's. All right, so therefore, if the independent variable is the right arm, therefore these are the X's and these are the Y's. So they don't have to plain out tell you now, but they will tell you in the question what it means by independent variables itself. Okay. All right, so now we just got to find the means of each one. So first is the y, so find the mean of that one. I got roughly 163.2 minus, and now our b naught, so our b1, so 1.315 times the mean of the x's. It'll be about 91. All right, so multiplying and subtracting, you should get a y-intercept at 43.565. So therefore, our regression line is going to be 43.565 plus, because it's positive. So for instance, if this was a negative, you put minus itself, right? So since it's a positive, it's just plus, like that. And there we go. There is our regression line itself. Okay. So next part we talk about is pretty lengthy, but it's actually pretty interesting as well, is prediction. So prediction basically means, okay, what do we use this line for? What's the most important thing? Okay, we can make sense, it puts the line through that fits them all out, but what's the most important thing just done there? You can just make a line itself. The good thing is, well, that predicts future events actually happening, believe it or not. So what we care about is what's happening in the future based off that information. And then this regression line helps us actually do that. Okay, so predictions is given an x value and a regression line, you can predict what the y values would be if you plugged in the x and solve for y hat. So essentially, if a patient comes in, let's say for this example here, with a right arm blood pressure of, let's say, 102, 107, right? Since 107 is not on here, I can plug in x being 107, and I can predict what the left arm blood pressure would actually be on that patient as well. And that's how it correlates when it comes to that kind of stuff. You could, stock markets, because they're huge about this. You can think of the stock market crash as a big part of the predictions, and also the house crash as well is a huge model of why these things actually happen for reasons and stuff like that. Okay? But here's an example we'll talk about on the bottom. So for example, let's suppose we have a data set comparing the sales of Halo game and the amount of time players slept per week. Pretty sure you didn't sleep if you guys played Halo when it first came out. Say it with me. The linear regression line model is given to you there. So they give us the regression line model, okay, where x is the where x variable is the sales of Halo, so how much it sold, right? And the question is, what would be the amount of time slept per week when the sales of the Halo was $55,000? So essentially what you would do is you would plug in $55,000 in for x, because that's what the variable told you to do, what it told you it is. You plug it in, and you see what we get. So we plug in 55,000 into R, and we get this, right? And just, order operations, multiply and subtract, and we set 47.34. So what this is saying is we predicted people would um, would sleep about 44.34 hours per week, which is very, very, very little, right, when it comes to it. So that's what we can bring when it comes to predictions, right? So we can always predict stuff happening in the future and interpret what that represents itself, which is pretty fun itself when it comes to it. Okay, so we'll talk about, again, more in focus predictions as well in the next video.